Hello students, this video is going to be on section 2.1, the greatest common factor or GCF. Again, we'll start this discussion by breaking down what these words mean. And again, the most important word is the last one, the word factor. A factor of something is a part of it. It's when we factor 10 to 2 and 5, we're looking at smaller parts. And factor is another word for divide as well. So it's a piece, a part of something else. Greatest means the largest, and common means the same, just as the LCM or least common multiple had that word common as well. But this one we're talking about the greatest common factor or part. We are going to start this the exact same way that we had started the least common multiple, which is by finding the prime factorization for all of the numbers we're interested in. And from there, instead of taking the largest exponent that we're going to see, because we're talking about a factor which is a part or a small piece, we're going to look for the smallest exponent. Okay, so an example of this, we will look at finding the greatest common factor of 60 and 48. Again, we'll start this the same way we were working on the other ones. And that is by finding the the prime factorization of each. Okay, so 60 factors down to 6 and 10. Neither of those are prime, so I need to keep working. 6 is 2 times 3, which are both prime now, and 10 is 2 times 5, which are also both now prime. So 60, I want to make sure I rewrite it like this so I can see the exponents as well. 60 is 2 squared times 3 to the first times 5 to the first. I have a single 3 and a single 5 in the prime factorization. Okay, now 48, there are several ways you could break this down. The first thing that I see is 6 and 8. So 6 times 8, neither of those are prime, I need to keep factoring. 6 is 2 times 3, which are both now prime. 8 is 2 times 4. 2 is prime. 4 needs to get broken down some more into 2 and 2. Okay, so 48 is 2, and let's see how many I have. 1, 2, 3, 4. So it's 2 to the 4th times a single 3. Okay, now that I have my prime factorization, I'll come over here and find the greatest common factor of 60 and 48. Greatest common factor of 60 and 48. So I'm going to still be looking at the exponents of my prime factorization, only now, because factor means smaller, I'm going to look for the smallest one. And so what I'm seeing are 2's, 3's, and 5's. So let's find the smallest the smallest exponent on 2 in our factors. This one has a 4 exponent. This one has a 2 exponent. The smallest I'm seeing is a 2. On to 3's, I have a 3 to the first and a 3 to the first. The exponents are the same, so that's got to be the smallest one. Our exponent is 1. Now, when I come to 5, I notice that there's a 5 here, a single one, but there's no 5 here. And therefore, there can be considered a 5 in this one to the exponent of 0. Because we know any number to the 0 power is 1. 5 to the 0 is 1. 200 to the 0 is 1. Any number to the 0 power is 1. And so, because the smallest exponent I have is really that there isn't a 5 here at all, I'm going to use a 0 exponent for 5. When I find the simplified version of this, I have 2 squared is 4, times 3 to the first is 3, times 5 to the 0 is 1. And so my greatest common factor of 60 and 48 is 4 times 3 is 12. That makes sense. Factor means part or smaller. Our number, 12, is smaller than 60 and 48. It's a part of both of those. I'll do one more example for you. This time I'm going to do 20 and 125. I start the same way. 20 is 2 and 10. 2 is prime. 10 is 2 and 5. These are both now prime. So my prime factorization for 20 is 2 to the second times 5 to the first. 125 is 5 times 25. You can check me using long division. 5 is prime. 25 is not. 25 is 5 squared, or 5 times 5, which are now both prime. 125 is 5 to the third. 1, 2, 3. So the greatest common factor of 20 and 125, the factors that I have here are 2 and 5. The smallest factor I have on 2, hopefully you remember that from my last example. This one has a 2 squared, but this one does not have a 2 at all. Therefore, I'm using the exponent of 0. 5, I'm looking for the smallest exponent. I have a 1 here and a 3 here. The smallest exponent is 1. And so I have 2 to the 0, which is 1, times 5 to the first, which is 5. And our greatest common factor of 20 and 125 is simply 5. One more example of one that's a little bit more complicated. This time we're using 3 numbers. And we are using 36, 126, and 60. Okay? 36 is 6 times 6. We've factored this recently, so we should know that it is 2 squared times 3 squared. 126, I don't know anything right off the top of my head other than this ends in a 6, so there's definitely a 2 in there. When you do the long division, you'll find that it's 63. When we factor 63, I know that 63 has a 3 in it. And when I do that, it's 21. Finally, 21, so sorry, 2 and 3 are prime. 21 is 3 and 7, which are now both prime. So 126 equals 2 to the first times 3 squared times 7 to the first. 60 is 6 times 10. 6 is 2 and 3. 10 is 2 and 5. 60 is 2 squared times 3 times 5 to the first for both of those. Okay? Greatest common factor of 36, 126, and 60. So all the numbers I'm seeing, I have a 2, I'm seeing a 3, I have a 5, and I have a 7. The smallest 2 exponent that I have 2 to the second, 2 to the first, and 2 to the second. The smallest is 1. For 3's, I have 3 squared, and 3 to the first. Smallest is 1 again. 5, I have a 5 here, but I don't have a 5 anywhere else, which means I'm going to make it an exponent of 0. And the same with the 7. I have a single 7, but no 7s anywhere else. So that gets a 0 as well. I have 2 times 3 times 1 times 1. Anything times 1 is the same thing. 2 times 3 is 6. The greatest common factor of those 3 numbers is 6. If you have any questions or aren't sure of any of this, please make a note and bring it up during class so that we can talk about it.